Okay, let's unpack this. We're diving into a stack of source material today, all about artificial intelligence, machine learning, and robotics.
Right.
Our mission in this deep dive is really to cut through the noise, pull out the most important nuggets, highlight the truly surprising bits, and give you a clear picture of where these technologies stand right now and the big questions they raise.
And if we connect this to the bigger picture, I mean, this isn't just future stuff anymore, is it? The material you've shared shows just how deeply integrated these technologies already are.
They really are.
Transforming industries from, retail and healthcare all the way through transportation and, loads more.
Exactly. And to start, the material lays out a definition for artificial intelligence, AI. Think of it simply as intelligence shown by machines.
Right.
It covers computer systems doing cognitive functions, things like learning, problem solving, but also perceiving their environment, analyzing data to figure out what's relevant, and then taking actions to, meet objectives.
And what's fascinating there, I think, is that it's not just about pre-programmed stuff. The definition really emphasizes systems that can learn and adapt.
Right, as they get new information.
Yeah. And under all that are the algorithms, those sequences of steps that let the machine solve problems or crunch numbers.
And the definition itself, it isn't static, is it? The sources point out how it keeps evolving.
Oh, definitely.
Technologies that once seemed super advanced AI, like optical character recognition, reading text from pictures.
Yeah, OCR.
Now it's so standard, it's often not even called true AI anymore. The bar just keeps moving up.
Absolutely. So given that kind of moving target, where is this intelligence actually showing up today, according to the material? The applications are just vast.
Let's maybe zero in on a few areas where the impact's really clear, starting with retail.
Okay, retail, good one.
You might think AI there is just about suggesting what you might like online.
Yeah.
And yeah, that's part of it.
Recommendations.
But the sources highlight how AI is being used to completely shape the shopping environment itself.
Shape it how?
Well, it learns from every single interaction, adapting both digital and, get this, even physical displays based on really complex customer profiles.
Oh, yeah. Okay, so not just online. And that goes hand in hand, I suppose, with changing the whole relationship a business has with its customers.
Totally. AI helps build this ongoing personalized connection. It adjusts your homepage layout, recommends products, not just based on past buys, but your real-time behavior.
Right, what you're doing now.
And here's where it gets really interesting from the material. The data they're pulling in, it goes way beyond just your click history or what you searched for.
Okay.
The sources mention the potential to include subtle cues like facial or even audio responses that could potentially reflect what customers are actually thinking or feeling in the moment.
Whoa. Okay, that's a surprising detail. Using facial responses.
Yeah, that's a level of insight, way beyond traditional surveys or focus groups.
Right. And AI uses that really rich, layered data to guide purchasing, power automated assistance. But it's also crucial behind the scenes, right? Using customer, competitor, market data for everything from the supply chain pricing, promotions,
Operations.
and even feeding into product development, analyzing purchase history, feedback, sentiment, to basically guess what products people will want next.
Wow. And that's just one sector. The material touches on so many others. In medicine and healthcare, AI is analyzing patient data to spot people at high risk for certain illnesses.
Enabling earlier prevention, yeah.
Exactly.
And it helps personalize treatments based on, a patient's unique history, even their genetics.
Then looking at transportation beyond the obvious self-driving cars.
Which is still a way off for most of us, but yeah.
AI is optimizing route planning, avoiding traffic jams, or even like roads in bad condition.
Agriculture too, you mentioned.
Yeah, using algorithms to monitor crops and soil health, predicting ripening times based on climate, helps farmers plan better.
Makes sense. And cybersecurity leveraging AI to spot anomalies in network traffic, trying to catch hacking attempts.
And sorting data by risk level.
Yeah. And even human resources, using AI to sift through resumes, figure out qualifications.
Job matching platforms predicting success.
Right. And helping candidates find roles based on their profiles. It's everywhere.
And finance. AI supporting investment strategies, high-speed trading algorithms making split-second decisions.
Impossible for humans. And the sources mentioned some investment portfolios are now entirely run by AI.
So, the takeaway here is pretty clear, right? The use of AI is just exploding. It's impacting nearly every facet of industry and daily life the sources cover.
Absolutely. And a huge chunk of that capability comes down to machine learning, or ML.
Right.
The material defines ML as using algorithms and data, specifically training data, to gain experience and learn tasks without being explicitly programmed for every single possibility.
And what's fascinating, the sources note, is that at advanced levels, these systems can actually get better at creating the algorithms needed than humans are.
Yeah, that's a bit mind-bending.
The relationship between AI and ML, it's a bit nuanced in the material, isn't it?
It is. Some views see ML as like a specific method to achieve AI. Others feel only the really advanced forms of ML truly count as AI. The definition's still a bit fluid, depending on who you ask.
Okay.
But the key output from ML, generally, is prediction, using historical data to forecast what might happen with new data.
Which then prompts actions or guides strategy.
Exactly. Guidance on how to hit objectives.
So the sources break ML down into types. First up, supervised learning.
Right. This type relies on labeled training data. Often involves human feedback, at least initially.
Okay.
It's about figuring out the relationship between known inputs and outputs. The material points to uses like bioinformatics, mapping biological processes, speech recognition.
And personalized marketing based on customer databases.
Got it. Then you've got unsupervised learning.
No labels here.
Exactly. The system gets unlabeled data and has to find patterns and structures on its own.
Like what?
Well, the marketing example cited is linking customers with similar buying histories to common traits, like age or location, discovering those connections without being told to look for them.
Interesting. And reinforcement learning. This one sounds cool.
It is pretty cool.
Yeah.
It's all about learning through trial and error to maximize some kind of reward.
Ah, okay.
It's useful when you don't have tons of training data or the goal isn't perfectly clear at the start. The system learns by, interacting with its environment.
Trial and error.
Yeah. Sometimes taking actions that seem maybe suboptimal short-term to gain knowledge that leads to bigger rewards later.
The long game again.
Precisely. The material uses examples like managing investment portfolios, controlling robots, improving strategy in games like chess or backgammon.
Okay. The sources also mention other interesting classifications like self-learning.
Yeah, and this is where it gets really mind-bending, I think.
How so?
Self-learning, as described here, involves no external rewards, no human guidance. The algorithm makes its own decisions and even considers emotions it was programmed with initially.
Whoa, hang on. Programmed emotions.
That's the term used. These emotions apparently respond to the consequences of its actions, guiding it towards its objectives and fulfilling these emotional needs.
Programmed emotional needs. That definitely makes you stop and think, wow.
And then there's deep learning, which the material flags is a hugely significant field right now.
Right, deep learning, hear that a lot.
It's based on artificial neural networks, kind of designed to mimic biological brains. It's especially good at analyzing unstructured data images, audio, text, using a nonlinear approach.
And the applications are everywhere, right? Recommendation systems.
Yep. Consumer apps, helping design drugs, analyzing medical images, real-time language translation. It's massive.
Okay, so we've looked at the intelligence and how it learns. Now let's pivot to how it interacts with the physical world through robotics.
Right. Robotics. The material defines it as developing machines, robots designed to reproduce human actions and often replace human labor in specific jobs.
And all robots have core features.
Yeah, a mechanical structure, electrical parts, and the programming code telling what to do.
Okay.
And the sources distinguish between robots needing human control versus autonomous ones. And crucially, they remind us robots aren't just, the humanoid shapes from sci-fi.
Right, they come in all shapes and sizes.
Exactly. Tailored to their job.
So where are robots proving most useful based on the material?
Generally, situations needing high accuracy and repeatability. That's where they shine compared to humans, who are better at creativity and flexibility.
Makes sense.
They're often used for jobs that are undesirable or dangerous for people. Think handling radioactive stuff, bomb disposal.
Right. Or environments humans just can't function in.
Exactly. Deep underwater, extreme heat.
And manufacturing is the classic example, I guess.
It really is. Robots can cut operating costs hugely, especially for tasks that are repetitive, monotonous, or need extreme precision.
Plus, they don't get tired. More reliable.
That's a big factor. The material uses welding as a specific case study.
Oh.
Robot welders mean higher productivity, less wasted material, higher quality yields because they avoid human errors. They can do complex welds humans can't, and they eliminate safety risks for workers. the flashing light, splatter, fumes.
Yeah, nasty stuff.
And machine vision, often linked with AI, gets integrated for quality control. Robots spotting defects early on.
Right, pulling faulty items off the line.
And in medicine, surgeons using robotic arms, sometimes controlled remotely.
Element manipulators?
Yeah, or computer control. The advantages mentioned are better precision, smaller incisions, meaning less blood loss, less pain for the patient.
That's significant. What about current developments?
The sources point to things like home robotics. Your robot vacuum cleaner is just the start.
Yeah.
And systems that can process and respond to their environment more dynamically. Robot learning is another big focus. Robots learning through exploring on their own or interacting with humans to pick up new skills.
But it's not all positive, right? The material mentions concerns.
Definitely. It's balanced. Initial investment costs can be steep. There's training needed for humans who have to work alongside these robots.
And safety.
Yeah. Health and safety risks when people interact with large, powerful automated machines. That's a real concern.
Which brings us neatly to a really critical part of this deep dive. The material spends a lot of time on the ethical side of AI, ML, and robotics.
Yes, referencing the World Economic Forum's focus here.
Right.
These are vital questions, way beyond just the tech capabilities.
So what are some of the key issues raised?
Well, points related to risk and control systems. It highlights that AI can make mistakes, but often different kinds of mistakes than humans might, like seeing patterns in random noise.
Okay. And bias.
Bias is a huge one. That AI systems, because they're built by humans or trained on human data, can reflect our existing biases, or just inadvertently encode bias criteria.
That seems hard to avoid completely.
It is. And increased AI power means you need much stronger cybersecurity to stop these tools being misused, plus the risk of unintended negative consequences. The AI does what you asked, but it causes other problems you didn't foresee.
Collateral damage almost.
Sort of. And then there's the big, maybe longer-term question the sources raise about ultimate control.
The sci-fi scenario.
Well, the idea is posed. Could AI eventually become too smart for us to manage, or even try to control us? It's out there as a consideration.
Okay. Provocative. Beyond control, what about economic and social impacts?
Unemployment is a major one discussed. The potential for humans to be replaced by AI and robots, leading to job losses, people struggling to find new work.
Which raises questions about societal support, right? What do we do?
Exactly. And tied to that is income distribution. If businesses can run effectively with way fewer people thanks to automation,
The profits might concentrate heavily at the top, with the owners.
that's the concern raised, potentially widening the gap between rich and poor.
The material also flags wider ethical issues, like machines influencing human behavior.
Yes. The specific example given is algorithms in video games designed to grab and hold your attention, with the potential to actually contribute to addiction. That's a very concrete example of influence.
Yeah, very relatable.
And here's that really thought-provoking point again. As AI reward functions get more complex, does giving negative feedback cause the AI suffering?
Right, the potential suffering point.
And if it does, or even if we think it might, does that create ethical duties for how we treat these advanced systems? It's pretty philosophical.
It really is. Given all these big issues, the sources mention suggestions like from the World Economic Forum for businesses using AI to adopt a clear ethical framework.
Yeah, basically say you need principles. Making sure AI ethics align with the company's general ethics, focusing on things like data protection.
And building ethics in from the start.
Right into product development. Thinking about data limits, privacy, getting feedback from customers and others is highlighted as crucial too.
And keeping an eye on bias continuously.
Yeah, being aware it can creep in and dealing with it. And finally, transparency. Being open about what data is used, how, why.
That seems key for trust.
Essential for reassurance, the material suggests.
So as we wrap up this deep dive, it's really clear from the material, isn't it? AI, ML, robotics, they're not just buzzwords. Their applications are incredibly broad.
Already reshaping countless industries, aspects of our lives.
From those surprising ways, AI is tweaking retail experiences to its vital roles in healthcare, manufacturing, finance. These techs are just woven into the modern world now.
But alongside all that power come these really profound ethical questions about risk, bias, jobs, money.
Influence over our behavior, even that long-term control question, and our relationship with sophisticated machines.
Yeah.
Understanding the sheer scope of these technologies and the ethical challenges they bring, as laid out in the material you shared, it feels essential.
It really does. They're transforming society and making us ask some pretty fundamental questions about the future.
The points raised in the sources definitely give you a lot to chew on.
Absolutely.
Thinking about that potential for AI to influence our behavior, maybe even contributing to addiction, or that really striking question about whether advanced systems could experience something like suffering. How should you, taking all this in, think about the responsibility we all have in shaping these technologies right now? As these systems get more complex, how might our ideas about consciousness and ethical treatment have to evolve too?